You really sure with your measurement? Measurement ba na siya or may unsurement ba na siya? So in conducting measurement, we need to develop in conducting measurement, we need to develop these skills, which are the accuracy and precision. So when we say accuracy refers to how close the experimental value is to the, or the average is to the accepted value. Why did I say average? Okay, so average because in conducting, in measuring an object, especially during laboratory, it is safe for us to say that we need to measure an object at least 3 times. So we need to measure an object at least 3 times. Sir, why do we need to measure that object at least 3 times? Because the greater or the greater the number of trials or attempts of our measurement, the lesser the the error, or the greater the accuracy level. So that is the reason why we have to, it is safe for us to say that we need to measure an object at least 3 times. So that is the reason why the experimental value is on the average. So when we say accuracy, it refers to how close the experimental value or the average is to the accepted value. So what does it mean when we say accepted value? Accepted value is the universal or the standard value of that particular object. For example, you tend to measure the boiling point of a water if it is. So the experimental value is the average of the 3 trials or the 3 attempts of your measurement on the boiling point of the water. And the accepted value of the boiling point of the water, we all know that the accepted value of the boiling point of the water is 100 degrees Celsius. So that is an example of an accepted value. So that is for the accuracy. So how about precision? What does it mean when we say precision or precise? So precision refers to how close a series of measurements are to one another. So if kanina, the accuracy rate or the accuracy means kung gaano siya ka-close to the accepted value or its true value. So now, precision means kung gaano ba ka-close ang ginawa mong measurement to one another. So for example, you attempt 3 times. So you have 3 trials in measuring the boiling point of the water. So the accuracy is if how close is the average of that measurement to the accepted value, while precision is if how close are those trials to one another. So for example, there is a 4 group conducted an experiment or measured the boiling point of a water. So as I have mentioned earlier, the boiling point of the water, the accepted value of the boiling point of water is 100 degrees Celsius. Okay, for the first group, they attempted 3 trials or they conducted 3 trials. So they have 101.2 degrees Celsius, 96.5 degrees Celsius, and 92.7 degrees Celsius. So those are the 3 measurement conducted by the first group. So the average of these measurements is 96.8 degrees Celsius. So I think you already know how to solve average or the mean of this given. So based on our average, we can say that it is low accuracy and low precision based on these given measurements. Why low accuracy? Because 96.8 is not close to 100 degrees Celsius. So low accuracy because it is not close to 100 degrees Celsius. So 96.8 is not close to 100 degrees Celsius, which is the standard or accepted value. Low in precision because we can see that the trial 1, trial 2, and trial 3 are not close to one another. So that is the reason why these measurements is low accuracy and low precision. So how about the measurement of the second group? For the second group, they have 104.2, 103.6, and 103.9. The average of this measurement is 103.9. 103.9 is not close also to 100 degrees Celsius. So therefore, we can say that it is low accuracy. But this time, it is high precision because 104, 103, and 103.9 are close with each other. So therefore, it is high precision. So for the third group, they have 102.5, 99.3, and 97.7. The average is 99.8. So, since 99.8 is close to 100 degrees Celsius, then we can say that it is high accuracy. But it is low precision because 102, 99, and 97 are not close with each other. Okay, last is the fourth group. The fourth group measured 99.5, 100.1, and 99.0. The average is 99.5. Okay, this time we can say that 99.5 is also close to 100 degrees Celsius. So therefore, it is high accuracy. And it is also high precision because 99, 100, and 99 are close with each other. So the fourth group has high accuracy and high precision. But the real question is, how close is close? Gaano ba talaga ka-close ang close? Paano natin masasabi that that particular measurement is paano natin masasabi that that particular measurement is close to its accepted value or that particular measurement is close to one another? So, to be able to say that it is close or not close, then we need the measures of accuracy and the measures of precision. But what are these measures of accuracy and measures of precision? Okay, so in measures of accuracy, we need to solve for each percent error. Percent of error give us the idea if that particular measurement is close to its accepted value or that experimental value is close to its accepted value. So we need to solve for its percent error. But how can we solve for its percent error? Then we have EV minus AV divided by AV times 100. So this is the formula for solving the percent error, and take note of this symbol. Okay? So take note of this symbol, which means the absolute value. So when we say absolute value, regardless of its sign, then it is always positive. So EV means the experimental value or the average of the measurement or the average of your measurements. So EV means the experimental value. While when we see AV, it is the accepted value. So when we say accepted value, it is the standard or the universal value of that particular object. So in this case, the boiling point of water is 100 degrees Celsius. So that is the accepted value of the boiling point of the water. So we have the average, which is the experimental value, and the 100 degrees Celsius, which is the accepted value. So substitute, we have 99.8 minus 100 divided by 100 times 100. So the result is a 0.2%. Okay, sir, ano 0.2%? Okay, according to the rule in the operation of significant figure, in multiplication and division, your answer should have the least number of significant figures. So in this case, the least number of significant figure is C 100, which only has one significant figure. So that is the reason that our answer is also in one significant figure. And go back to the percent error. So percent error 0.2%. So what does it mean when we say 0.2%? Okay, so when it is 0.2%, or how can we identify if that percent error is high accuracy or low accuracy? So if the percent error is less than or equal to 5.0%, okay, take note, if the percent error is less than or equal to 5.0%, then it is high accuracy. Then that particular measurement is high accuracy. So in this case, since 0.2% is less than 5.0%, then we can say that this data or this measurement is, the level of this measurement is high accuracy. Okay, so why high accuracy? I repeat, because 0.2% is less than 5.0%. Okay? So that is for the measures of precision, measures of accuracy. So using the percent error, we can identify if the accuracy is high or low. So to identify if it is high or low, if the percent error is less than or equal to 5.0%, then the level of accuracy is high. Okay, so how about the measures of precision? How can we identify the level of precision? So in measures of precision, we need to use the standard deviation to be able to identify the level of its precision. So I think you are familiar with the standard deviation. So you already discussed this during your statistics. So I think you are familiar already with the standard deviation. So in measures of precision, we need to use the standard of deviation. So to solve for its standard deviation, we have the square root of the summation of the square of r sub I minus r sub average divided by n sub 1, where r sub I is the initial trial. When we say initial trial, those are the trials you have conducted. So if you have 3 trials, for example, in this case, the students conducted 3 trials. So we have trial 1, initial trial 2, and initial trial 3. Okay. R average or the trial average is the average of your trials. And last is N is the number of trials. Okay, so if we solve for the summation of the square of R sub I minus R sub average, so here we have the initial trials, 99.5, 100.1, and 99.7. So initial trial minus average, so we have initial trial minus average is 0.3, then square is 0.09. So 0.3, 0.09, then negative 0.1, square is 0.01. Okay, so add, so the summation of R sub I minus R sub average, or the summation of the square of R sub I minus R sub average is equal to 0.19. So substitute, so 0.19 divided by 3 minus 1. So the result is 0.10. So from 0.10, the square root of 0.10 is 0.3. Okay. Sir, ngano 0.3 lang man? Sir, ngano 1? Why is it that it is only in one decimal place? Okay. Your standard deviation is always in one significant figure. Sir, why is one significant figure? Okay, take note. Based on our formula here, so 0.19 has two significant figure. 3 minus 1 is 2. And 2 only has one significant figure. So according to the rule of the multiplication, always follow the least number of significant figures. So if 2 only has one significant figure, so therefore, your answer should also be in one significant figure. Sir, asa ba na mo i-apply ang rules of significant figure? Okay. Apply the rules of significant figure at the end of your solution, or at the kumbaga sa answer. So apply the rules of significant figure at the end of your solution, or kumbaga sa answer. But always take note of the rule, and always take note of the number of the decimal place and the number of significant figure, so that you can apply the rule in significant figure. For example, in this case, we only have one significant figure on this given example. So therefore, if we only have one significant figure on our given, according to the rule, that the answer should have the least number of significant figure. So that is the reason why the answer is also in one significant figure. Okay? And what does it mean when we say, okay, let's go back to the measures of precision. So what does it mean when we say that the standard deviation is equal to 0.3%, 0.3? So what does it mean when we say that the standard deviation is 0.3? Okay, sir, how can we say if it is high precision or low precision? What is our basis to be able to identify what is our basis to be able to identify what is the level of its precision? So to be able to identify the level of its precision, always remember that if the standard deviation is less than or equal to 1, then it is high precision. If the standard deviation is less than or equal to 1, then it means high precision. And if the standard deviation is greater than 1, then it means low precision. Okay? So, same with the measures of accuracy, it is always less than or equal. So, if it is less than or equal to 1, then it is high precision. If it is greater than 1, then it means a low precision. So, go back to the example. So, the standard deviation is 0.3. So, since it is less than 1, then it means a high precision. So, since it is 0.3, then it means high precision. But sir, how can we report our measurement? So paano namin isulat ang aming measurement, or how can we report our measurement? So report your measurement as the average, which is 99.8 degrees Celsius, plus or minus the standard deviation, which is 0.3 degrees Celsius. Okay. Take note, both are on the tens place. Why on the tens place? Because the average of your measurement should be matched to the uncertainty, or the average of your measurement, or match the measurement to the uncertainty, or also known as the standard deviation. So, you have to match the place value of your measurement to the place value of your standard deviation. Okay, for example, in this case, since the place value of our standard deviation is on the 10th place, so therefore, the average of our measurement, or the measurement, is also on the 10th place. But if our standard deviation is on the 1st place, then our measurement should also be on the 10th place. Okay? Okay, so I repeat, if the percent error is less than or equal to negative 5.0%, then it is high accuracy. If it is greater than 5.0%, then it is low accuracy. And if the standard deviation is less than or equal to 1, then it is high precision. But if the standard deviation is greater than 1, then it is low precision. So let's have another example. So these are the data gathered by some students. So we have the 3 trials. So the percent error is 3%. So since 3% is less than 5, so therefore we can say that it is high accuracy, or the level of accuracy is high, since 3% is less than 5.0%. Okay, next, for the standard deviation, or the measures of precision. So 101.2 minus 96.8 is 4.4, then square 19.36. So the summation is 36.26. So 36.26 divided by 3 minus 1 is equal to 4. So since we only need one significant figure, square root of 18.13 is 4.4596, I think. So since we only need one significant figure, so we round it to its ones place. So 4 is the one significant figure. So since our standard deviation is on the ones place, or it is whole number, so therefore we need to match the place value of our measurement and our standard deviation. So from 96.8, since it is whole number, we round our average to a whole number, to its ones place. So from 96.8, it will be reported as 97 degrees Celsius plus or minus 4 degrees Celsius. Okay? So that's it for the measures of accuracy and measures of precision. Okay, speaking of measures of accuracy, which is the percent error. Okay, so sir, is there a chance where the percent error is equal to 0.0%? Okay, so far I did not encounter any measurement which has a percent error of 0.0%, because no matter how careful we are, there is an error, or there is always an error in our measurement. But what are the types of error that we can encounter in our measurement, and what are the sources of these errors? So mainly we have two types of errors. So what are these two types of errors? So the types of errors, we have the systematic errors and the random errors. So first, what is a systematic error? So when we say systematic error, then it means deviation from the accepted value, and it reduces accuracy. So when we say systematic error, it is a deviation from the accepted value, or a deviation from the true value, and it reduces accuracy. So how about the random error? So this is the error that reduces accuracy. So how about the random error? When we say random error, then it deviates from the measurement, or among the measurement. It is a deviation among the measurement, and it reduces precision. So when we say systematic error, it deviates from the accepted value because it reduces accuracy. And when we say random error, it deviates from the, or among the measurements only, and it reduces precision. But what are the sources of these errors? So mainly, we have different type of sources of errors, but I will just introduce to you some of it. So first, we have the precision of errors. Okay, precision of errors, especially when you are not familiar with the, if you are not familiar with the, what do we call, the instrument. So there is a precision in error. Your measurement, or there is a precision of instrument. So your measurement using that particular instrument is not precise with each other. So for example, in this case, so the trial 1, 0.41, for trial 2, 0.39, and for trial 3, 0.43. So there is a precision on our precision of instruments. So there is a precision among the measurements that you have conducted. So that is an example of sources of error. Another type of source of error, we have the scale error. When we say scale error, it is inaccurate calibration. When we say inaccurate calibration, then your measuring device or your instrument is not properly calibrated. For example, in this case, it is also the same with the zero error, which is not properly calibrated. For example, in this case, as you can see, this is the pin of the triple beam balance, and this is the line for the 0. As we can see, it is not properly aligned. Unlike the second example, which is properly aligned. So the black image is inappropriate or not properly calibrated, and the white image is properly calibrated. So that is the 0 error. Okay, next is the parallax error. When we say parallax error, it is an appropriate eye level. So in using test tube, you need to make sure that the test tube is on your eye level. If not, then that is the source of error, which what we call the parallax error. We also have the environmental error. So these are errors caused by the anything that surrounds you, or error caused by the environment. So anything that surrounds you may cause error. So uneven surface, so the winds, so those are environmental error. We also have the reaction time. Reaction time is an error caused by the delay of reaction. So that is a source of error.